Configure basic router settings. Up to now, this module has only covered switches. So if you want devices to be able to send and receive data outside of your network, you will have to configure routers. This topic teaches you basic software configuration and provides two syntax checker and a packet tracer activity. So you can practice these skills. Cisco router and Cisco switches have many similarities. They support a similar model operating system, similar command structures, and many of the same commands. In addition, both devices have similar initial configuration steps. For example, the following configuration tasks should always be performed. Name the device to distinguish it from other router and configure password as shown in the example. So, this is the example code of the packet tracers. So, first, we need to configure terminal. Configure terminal means this command is then used to enter global configuration mode. After entering this mode, the prompt changes to indicate that you are now in the global configuration. And then hostname main is the name of the hostname is the R1. Then the enable secret, the line console 0 command is used to the device configuration mode to access the configuration settings for the console port. For example, you might use this command to set parameters such as baud rate, parity, and stop bits for the console connection. And then the password is Cisco, then login, exit. Line BTY04 means that line 04 line BTY04 means that the BTY stands for virtual terminal, and the 04 refers to the range of virtual terminal lines from 0 to 4. These lines are used to telnet or SSH access to the device. So configure a banner to provide a legal notification of unauthorized access, as shown in the example. So this is the example of the configure a banner, and then after that you save the changes on a router as shown in the example. So syntax checker or configure basic router settings. So in this syntax activity, you will configure basic settings for R2. So this is how you this is the example code of how you configure the basic setting of R2. So dual stack topology. One distinguished feature between switches and routers, the type of interface supported by each. For example, layer 2 switches support LANs, therefore they have multiple fast Ethernet or gigabit Ethernet ports. The dual stack topology in the figure is used to demonstrate the configuration of router IPv4 and IPv6 interfaces. So the dual stack topology devices and network infrastructure support both IPv4 and IPv6 protocols. So here is the picture of the dual stack, R1 and the R2. So configure routers interfaces. Routers support LANs and WANs and can interconnect different types of network. Therefore, they support many types of interfaces. For example, G2 ISRs have one or two integrated gigabit Ethernet interfaces and high-speed WAN interface card slots to accommodate other types of network interfaces, including serial, DSL, and cable interfaces. And to be available, an interface must be configured with at least one IP address. Use the IP address subnet mask, and the IPv6 address and the IPv6 address prefix interface configuration command. Activated by default LAN and WAN interfaces are not activated or shut down. To enable an interface, it must be activated using the no shutdown command, and this is similar to powering on the interface. The interface must also be connected to another device, a hub, a switch, or another router for the physical layer to be active. So the description means optionally the interface could also be configured with a short description of up to 240 characters. It is good practice to configure a description on each interface. On production network, the benefit of interface description are quickly realized as they are helpful in troubleshooting and in identifying a third-party connection and a contact information. So the following example shows the configuration for the interfaces on R1. So the R1 hostname is configured. Interface gigabit Ethernet 000 means that the notation gigabit Ethernet 00 typically represent the interface identifier, and it can vary depending on the specific device and its configuration. And the meaning of this, the 000 means that this is the interface identifier in the example. It suggests that it is the first gigabit Ethernet interface on the first line card or module particular slot. So this is the code of how you configure for the interfaces on R1. And a syntax checker configure router interfaces. In this syntax checker activity, you will configure R2 with its IPv4 and IPv6 interfaces. So Kani is the R1 host, R1 host name, then R2 host name. So to configure gigabyte interface 0 is use G00 to enter interface configuration mode, then configure the IPv4 address, the 10.1.1.1, and the subnet mask is the 2.255.255.255.0. Then configure the IPv6 address and then describe the link as link to LAN 3. Activate the interface. And then to configure the gigabit serial is the configure gigabit internet 001, and so on and so forth. So this is the continue of the code. So description link to R1. So what is the IPv4 loopback interfaces? Another common configuration of Cisco IOS router is enabling a loopback interface. The loopback interface is a logical interface that is internal to the router, and it is not assigned to a physical port and can never be connected to any other devices. It is considered a software interface that is automatically placed in a state as long as the router is functioning. So the loopback interface is useful in testing and managing a Cisco IOS device because it ensures that at least one interface will always be available. For example, it can be used for testing purposes such as testing internal routing processes by emulating networks behind the router. Loopback interfaces are also commonly used in lab environment to create additional interface. For example, you can create multiple loopback interface on a router to simulate more network for configuration, practice, and testing purposes. In this curriculum, we often use a loopback interface to simulate a link to the internet. And then the syntax checker configure router interface. So enabling and assigning a loopback address is simple. So you can use the word the interface loopback number and then the IP address subnet mask, which is this. So here is the example of the code. Then the packet tracer configure router interface. So here is the steps to configure the router interfaces. And we did this in the part 1 of our Cisco. So interface verification commands. There is no point in configuring your router unless you verify the configuration and connectivity. This topic covers the command to use to verify directly connected network. It includes two syntax checker and a packet tracer. There are several show commands that can be used to verify the operation and configuration of an interface. The topology in the figure is used to demonstrate the verification of router interface settings. So the following commands are especially useful to quickly identify the status of an interface. Show IP interface brief and show IP basic interface brief. Then this display a summary for all interfaces, including the IPv4 or IPv6 address of the interface and current operational status. Show running config interface ID. This display the command applied to the specified interface. And that's show IP route and show IPv6 route. This display the content of the IPv4 or IPv6 routing. The table stored in RAM in Cisco iOS 15 attribute. Interfaces should appear in the routing table with two related entries identified by the code C connected or IL local. In previous iOS version, only a single entry with the code C will appear. So to verify the interface status is the output of the show IP interface brief and show IPv6 interface brief command can be used to quickly reveal the status of all interfaces on the router. So you can verify that the interfaces are active and operational as indicated by the status of app and protocol of app as shown in the example, and different output would indicate a problem with either the configuration or the cabling. So this is it means if app ang makabutang, so pag app ang nakabutang, so it means that the interfaces are active. So ayun siya. So to verify the IPv6 link local and multicast addresses, the output of the show IPv6 interface brief command is displayed to configure the IPv6 address per interface. Then one address is the IPv6 global unicast address that was manually entered. The other address which begin with the if A80 is the link local unicast address for the interface. Local address is automatically added to an interface whenever a global unicast address is assigned, and the IPv4 network interface is required to have a link local address but not necessarily a global unicast address. So the show IPv6 interface gigabit internet 000 command display that the interface status and all of the IPv6 address belonging to the interface along with the link local address and global unicast address. The output includes the multicast address assigned to the interface beginning with prefix FF02 as shown in the example. So this is the example of what I mean, the FF02. And then to verify the interface configuration, the show running config interface command display the current command applied to the specified interface as shown. So look at the code, and in the following the two commands are used to gather more detailed interface information. Then show interfaces display the show interfaces displays interface information and packet flow count for all interfaces on the devices. Show IP interface and show IPv6 interface. Yes, display the IPv4 related information for all interfaces on a router. So verify routes. The output of the show IP route and show IPv6 route command reveal the three directly connected network entries and the three local host route interface entries as shown in the example. So the local host route has an administrative distance of 0, and it also has a 32 mask for IPv4 and 128 masks for IPv6. The local host route is for route on the router that owns the IP address. It is used to allow the router to process packets destined to that IP. So this is the example code or the code of the to verify the routes. So here use the command show IP route and it will display and should and there use the show IPv6 route command to show the so a letter C next to a route within the routing table indicate that this is a directly connected network. So it means that a letter C is a directly connected network. When the router interface is configured with a global unicast address and is in the app or app state, the IPv6 prefix and prefix length are added to the IPv6 routing table as a connected route. So the IPv6 global unicast address applied to the interface is also installed in the routing table as the local route. The local route has a 128 prefix. Local routes are used by the routing table to efficiently process packet with the interface address of the router as the destination. And the ping command for the IPv6 is identical to the command used with IPv4 except that an IPv6 address is used. So as shown in the example, the ping command is used to verify layer 3 connectivity between R1 and PC1. So here is the R1, the ping is this is the ping. So the filter show command output, the commands that generate multiple screen of output are by default. Pause after 24 lines at the end of the pause output. The more text displays, pressing enter displays the next line and pressing the spacebar displays the next set of lines. So use the terminal length command to specify the number of lines to be displayed. A value of 0 prevents that the router from pausing between screens of output. Another very useful feature that improves the user experience in the CLI is the filtering of show output. Filtering commands can be used to display a specific section of output. To enable the filtering command, enter a pipe character after the show command and then enter a filtering parameter and a filtering expression. There are four filtering parameters that can be configured after the pipe. So the section is show the intersection that start with the filtering expression as shown in the example. So this is main. So they include all output lines that match the filtering expression as shown in the example. The exclude means exclude all output line that match the filtering expression as shown in the example. The begin last is show all the output lines from certain point starting with the lines that matches the filtering expression as shown in the example. So syntax checker filter show command output. In this syntax checker activity, you will filter output for show command. So show running config section line con 0 is the password is the 7050880F1C2243 and the transport input is none. So command history feature. The command history feature is useful because it temporarily stores the list of executed command to be recalled. To recall command in the history buffer, press Ctrl P or the up arrow key. The command output begins with the most recent command. Repeat the key sequence to recall excessively older commands. To return to more recent command in the history buffer, press Ctrl N. So you use Ctrl N or the down arrow key. Repeat the key sequence to recall successively more recent command. By default, command history is enabled and the system capture the last 10 commands line. In this history buffer, use the show history privilege exec command to display the content of the buffer. It is also practical to increase the number of command lines that the history buffer records during the current terminal session only. Use the terminal history size user exec command to increase or decrease the size of the buffer. An example of the terminal history size and show history command is shown in the figure. So this is the example or the code, the command. Then the syntax checker command history feature. So this is the syntax checker of the command history feature. So packet tracer verify directly connected networks. So this is how you this is the steps of how you verify the connected network.